Hi, this is Perry from Reach It, and this is another draft video that I've put together to my video team for them to prepare a professional video that you can then add to your SOPs and your training regime. This video is all about flow. Flow is a constant, right? And then what does that mean? And then what do we do about that? So flow equals pressure times resistance. So we're gonna give you two other videos, one on pressure and one on resistance. And I think you'll find them very educational. You can use them now. The information's yours, but actually the finished module's coming later. But we think you'll enjoy the journey of seeing something turning from an idea into a reality, and being able to be used professionally, through everybody's businesses. So enjoy it. So this video is what to do about pressure. Just understanding really simply that if we bundled up all of our hose and tube and filter and we just called it a water delivery system, then we basically have water in to our water delivery system and we have water out of our water delivery system to a brush, right? And then these are our jets. So we have two things that we have to work with. Flow is always a constant, right? So flow equals a constant. Now, if flow is always a constant, what does that mean? Does that mean that the flow rate here is a constant there? No. What it means is that at any cross-section, flow is a constant. So we can have a cross-section there, we can have a cross-section here, we can have a cross-section here, we can have a cross-section here, or a cross-section here. Anywhere in the system you have a cross-section. At that cross-section, the flow rate is a constant. So if we take it at the jets, then we can say, okay, if the flow rate at the jet is 0.5 GPM, right? Then that is a constant. If we have one jet open, then that's going to be, one jet is a lot of resistance. So you basically have, if you look at it, you have water flowing in this direction. It then comes down into a resistance. And then this water, with this volume of water, maybe there's 2 GPM, coming through, it's trying to push 2 GPM, 0.5 GPM, looking over here, trying to get through this one little jet, yeah? That's your resistance. So because it can't get through that jet easily, it creates a back pressure, and that's what creates your PSI, that's your pressure, right? So then it's now, in order to get through there with the flow rates, trying to push 0.5 gallons per minute through a 1/24 inch hole, that water is going to squirt like crazy, right? And that's how, for example, pressure washers have pressure washing systems. They have a lot of water pushing through with a pump that can go to a massive amount of pressure through a tiny little hole, and the velocity through the hole becomes really, really aggressive. Right? Now, if you take that same experience and you take it into a series of jets that are open in a rinse bar, like Hydroblade, now, if these are the same size as this one, now let's say you have, 20 to 30 jets open. Now this water, because it's open, there's less, the PSI is less, yeah? So the PSI has dropped, but the flow rate is the same. So that 0.5 gallons per minute that's pissing through there will be 0.5 gallons per minute coming through 30 jets. So it might only, this might squirt, 10 feet, and this might squirt, 18 inches, yeah? And so it's that understanding that there's two ways to do it. We either boost the pressure into the system, or in order to get more velocity, in order to get the jet to squirt further, or we increase the resistance. And you increase the resistance by having less jets open. Now there's another way. You can have a look at any part in that system and say any part of that system. Like if you've got 300 feet of hose or tube, then it's going to have a resistance. So you want to reduce the resistance. So you say if I have 100 feet of hose or tube, that 100 feet of hose or tube will have less resistance. So you'll end up with more water and a higher flow rate. That will give you more flow rate here. And then the how far those jets squirt depends on that flow rate going through how many holes that are open. Okay, so at any cross section, the flow rate is a constant. You change the resistance, you make the resistance smaller, the back pressure builds up against the resistance. Like here, there's this turbulence point here. The back pressure builds up against the resistance, and then the velocity of the liquid through the resistance is greater. More holes open, less resistance, pressure is less because there's less back pressure, but the same amount of water will come through from that cross section